let's take a look at Geospatial AI, our recent advancements and what it can do for you. Let's get started by defining what it is. Geospatial AI applies spatial machine learning and deep learning techniques to help solve complex problems and derive deeper insights in very powerful and innovative ways. And as we do this, we are expanding the power of GIS itself to support two kinds of systems. In assisting humans, which we call human in the loop, so the expertise of humans comes in along with augmentation from AI, and then building fully autonomous systems itself. ArcGIS is an end-to-end geospatial AI system. By that, what I mean is right from the time you access the data and prepare it for labeling, all the way through model training, QA, and validation to inferencing and being able to inference at scale in production environments. And then, of course, the loop back into taking the right decisions based on the outcomes from these inferencing methods. All of this is possible within the system, but when you look at it from a user point of view, you can experience geospatial AI in different ways. First, it starts with the core of it, arcgis.learn. It's a module within the Python API. And within that, you can do everything that I showed in the end-to-end system. And then if you went beyond, we have pre-trained models that are readily available for you to deploy into production. We spent a lot of compute and curated data to come up with these models and validate them. For some of you, it'll be ready for use. For some other cases, you might want to bring in your own data and do some transfer learning. It's like a localization process, you can say, and then you can validate and deploy it to production. And then there's the aspect of bringing these models as ready-to-use tools within ArcGIS that you're always familiar with, analytic tools. There, it's like geoprocessing that is coming through. And lastly, some of you are building ready-to-use apps and solutions. And in this case, the fact that it has AI in it is unseen to the user. You just use it because it's better. Today, we are excited to introduce a few of our users, developers, and data scientists to show you the use of geospatial AI in real projects. I'd like to introduce Rohit, who's going to take us on a quick tour. Rohit?
I'd like to take you on a tour of geospatial AI. And as we go on that tour, I'd like us to make stops at 4 cities around the world where you, our developers and users, are taking AI to the field and solving real-world problems. So let's get started. When we talk about geospatial AI, it really spans ArcGIS, but at its core, it begins with the arcgis.learn module of our Python API. This module makes it super easy to train a wide variety of geospatial deep learning models on your data. You can bring in data from ArcGIS, feed it into any one of the 30 or so geospatial deep learning models that we have support for, fit the model to the data, and once you're satisfied, save it out as a deep learning package that you can then use with ArcGIS. This module has support for oriented and overhead imagery, 3D point clouds, featured, tabular, and time series data, and even unstructured text. We have models for nearly every kind of feature extraction task from imagery, including models for object classification and object detection, and for pixel classification and instance segmentation. We have recently added models for edge detection that can be used for extracting residential and agricultural parcels, a state-of-the-art model for road extraction, as well as models for change detection and for image translation, both from other images as well as from images to text, that is, image captioning. For 3D data, we have the Point CNN point cloud classification model. And at this release, we have added support for processing mobile point clouds, as well as the ability to use multiple models with one point cloud for categorizing buildings, trees, and ground points in this example. To complement the geoprocessing tools in ArcGIS Pro, the fully connected network allows you to take data from feature layers and feed it directly into a deep neural network, giving superior results compared to most machine learning models provided you have enough training data. Speaking of which, the machine learning model, we call it ML model, It lets you easily integrate ArcGIS with any classification, regression, or clustering model from the popular scikit-learn library. Another feature that I'm very excited about is the addition of the time series network to ArcGIS Learn. This model brings the power of deep learning and convolutional neural networks to time series forecasting. Now, geospatial data doesn't always come packaged in file geodatabases and shapefiles. It's often in an unstructured format such as text-based reports. That's another area where deep learning has done exceedingly well. And at this release, we have added an entire submodule called arcgis.learn.text for natural language processing. With the entity recognizer model, you can extract geospatial information from the reports that you just saw and bring them to a map. The module also has models that can take in incomplete addresses and determine the country they belong to with near perfect accuracy, or automatically correct spelling mistakes in addresses and normalize them to a standardized format that's suitable for geocoding. But you don't have to train all such models yourself. The text submodule lets you use open source NLP models for these tasks and more. And what's great is that such models are available for English as well as several other languages. So to recap, ArcGIS Learn is a module of ArcGIS API for Python and has support for dozens of geospatial deep learning models. I can't wait to see what you do with them. Let's now go to Kuwait to see how PASI, the Public Authority for Civil Infrastructure, is keeping their base maps updated using arcgis.learn. Over to you, Maher.
State of Kuwait is executing huge infrastructure projects all over the country in order to achieve the 2035 country vision. Coping with these changes is very challenging. The Public Authority for Civil Information, PASI, is responsible to record data about people, addresses, and businesses. We have created a comprehensive base map for the whole state of Kuwait, which is used by more than 170 different organizations. We have released a GIS-based hyperlocal search application called Kuwait Finder with more than 1.2 million users. We have recognized the need to modernize our business process to update the GIS data, starting by exploring how we can use machine learning and deep learning to do this. We analyzed Kuwait Finder GPS logs and satellite imagery in order to identify gaps in our street networks and GIS data. Let's see how we did it. We have selected Airbus 2018 image as our baseline, and we created our ground truth data, distribute them all around the country. We selected to create 3 different classes: building footprints, streets, and parking lots. We used ArcGIS API to do the model training. We exported the data, prepared data in order to validate it. We selected Deep Lab with ResNet 152 as our backbone. We trained the model different times, and each time we are starting from the point that we have ended at in order to increase the model accuracy. And this is the output of the model. Running this prediction of over 600 square kilometers, we had around 111,000 building footprints, around 78,000 street segments, and around 2,600 parking lots. Usually this needs around 74 days to digitize them. We achieved this by 1.5 hours of processing and 2 days for quality control and quality assurance. And you can see the boost of efficiency. In our way to support Kuwait Vision 2035, using deep learning in PASI, we are able to enhance our efficiency, be able to provide timely and accurate data, and make our data accessible to our users. Please drop us a visit. Thank you.
Thank you, Meher. ArcGis.learn makes it really easy to train deep learning models on your own datasets, but we recognize that not everyone knows Python or has the vast amounts of training data, imagery, and GPUs that you need to train good models. With the release of pre-trained geospatial deep learning models on Living Atlas, we are now making deep learning easier than ever. We have models for building footprint extraction and land cover classification, 3D models, as well as models for extracting roads and human settlements from Sentinel and Landsat imagery. These models are built upon ArcGIS Learn and have been pre-trained by Esri on huge volumes of data and can be readily used to automate the tedious task of digitizing or extracting geographical features from imagery or other geospatial datasets. Here are some results of our building footprint extraction model. While it's trained on data from the United States and designed to work best there, it performs fairly well in other parts of the globe. We just need to point the Detect Objects tool in ArcGIS Pro at the RGB imagery, and the model does the rest for us in a matter of minutes. In addition to being used as is, these models also serve as base models that you can further fine-tune on your geography or the task at hand. To see an example of that, let's now go to New Delhi, where Saranya from Esri India will show how they further fine-tuned our pre-trained models to extract railway assets and their precise dimensions from point cloud. Over to you, Saranya.
During field inspections, the dimensions of the railway assets are measured manually, which is not only time-consuming but also prone to human errors. Our client L&T decided to automate this process using mobile LiDAR point cloud data. They approached Esri India to create an end-to-end workflow to classify these point clouds and extract the measurements for the trains to run safely. We use deep learning to classify our railway assets such as power lines, poles, cantilevers, and railway tracks. To the left, we have the point cloud data of a railway asset, and on the right, we have all the necessary measurements that needs to be extracted. We started our workflow with power line classification model, which is a pre-trained model available on Living Atlas. We chose this model as it was capable of classifying two of our objects of interest, power lines and poles. To the left, we have the input data, and in the center, we have the output from power line classification model. Even though this model was trained on electric wires and poles, it gave good result in railway asset data as well. But we needed much higher accuracy in our predicted output, as our goal is to extract extremely precise measurements of these complex objects. So we went with transfer learning. We fine-tuned the pre-trained model with a small subset of manually labeled data. To the right, we have the output from transfer learning. Due to the head start we got from pre-trained model, we were able to save a lot of time, cost, and compute resources. We even got very high precision and recall compared to what we could have achieved if we had to train the model from scratch on a small subset of manually labeled data. Let us take a quick look at our notebooks. Here we have the necessary imports. In this section, we are preparing our data for training. Here, we are fine-tuning our pre-trained model with manually labeled data. Similarly, we trained a new model from scratch to classify the rest of our objects of interest, railway track and cantilever. At the end, we combine the outputs of these two models using selective classification and class preservation functionalities available in the API. To the left, we have the output from the fine-tuned model. In the center, we have the output from new model. And in the right, we have the combined output we got using new functionalities in API. Now our data is accurately classified and it is ready for analysis. We used Model Builder framework to automate the dimension extraction process. Using several geoprocessing tools in ArcGIS Pro, such as density-based clustering, minimum bounding volume, and zonal statistics, we were able to extract dimensions such as pole heights, centerline geometry of the railway track, catenary height and contact height, and even complex measurements such as top fitting and bottom fitting. Not only this, all the measurements we extracted were found to be in conformity with the ground truth. Thank you.
Thank you, Saranya. That's very powerful. And we are making it even easier. ArcGIS Pro has been enhanced with a number of tools that let GIS analysts take advantage of these models and even create or further fine-tune them on their datasets without needing to know Python or much about deep learning. The deep learning tools in Image Analyst have been extended to work with multispectral imagery at this release. For the next release of ArcGIS Pro, we are bringing deep learning to full motion video. Let me now hand it over to Atishay from Esri's R&D Center in New Delhi to show us a demo of that.
Thanks, Rohit. Now, let's have a look at a few ways in which object tracking can be used to get the most out of full motion video data. First, we'll understand how we can use full motion video extension in ArcGIS Pro to analyze videos and capture critical information which can be saved directly to a geodatabase. In this example, let's track this truck as it moves along the road. We can use Annotate Points tool to drop points on the truck. The map on the right shows the geographical coordinates of these points along with the trajectory of the camera. In ArcGIS Pro 2.8, we're adding support for deep learning based object trackers which can automate this workflow to a great extent. We can pick a pre-trained object tracking model from the Living Atlas or use arcgis.learn, which allows us to fine-tune a pre-trained model using data specific to our use case. Let's have a look at how we can train such models. The Learn module has APIs to prepare data for training, load an existing pre-trained model, and fit the model. Once the model has been trained, it can be converted to a format which can be used in the object tracking tool of FMV. We can load the trained model, add the object to track, and the object to feature tool automatically drops points on the map as the object moves while saving the data to a geodatabase. Not only that, the tool has intelligence to detect track failures and recover lost objects. Should there be a need to reposition the object, we can easily do so and continue tracking it. Another capability is simultaneous use of object detector and object tracker for certain applications. For example, the green box here represents a region of interest near the entry-exit gate of a parking lot. Our goal is to estimate the number of cars passing through this region. Object Tracker class in arcgis.learn helps us pair object detection models such as RetinaNet and object tracking models such as CMask. After reading frames from a video using OpenCV, we detect cars in the region of interest and track them. The total number of tracks helps us arrive at the final count of cars. To sum up, the two examples that we have seen demonstrate the power of object tracking in automating critical business workflows. Over to you, Rohit.
Thank you, Atishay. It's great to see these capabilities coming to Image Analyst. Another feature that I'm very excited about is the upcoming release of deep learning tools for point cloud classification. These tools build upon the point CNN model in ArcGIS Learn, and they will ship with ArcGIS Pro 2.8 in the 3D Analyst extension. And we now also have a new tool for interactive object detection in 3D scenes. In this example here, it's using the pre-trained doors and window detection model from the Living Atlas. To see how it works, let's now go to Tel Aviv in Israel, where Igal from Systematics will show us how they are using it for line-of-sight analysis. Over to you, Igal.
Here's an example of deep learning being used in ArcGIS Pro 2.7 to detect objects in the view on the fly, create point features from them, and then use the points to analyze line of sight. Esri provides a ready-to-use model to extract doors and windows, but you can use your own model. The model list will expand in future releases. Here, We have some great integrated mesh content from Ofek Aerial Photography. This is 3 cm resolution in the center of Jerusalem, Israel. We can see here a large construction site. First, I would like to zoom to the east front of this architecturally interesting office building. I'm going to enable the object detection tool, which we can find in the 3D exploratory analysis tool. And here we can see the model, Esri Windows and Doors, which I have downloaded in advance. Next, we will specify the type of asset we're interested in. I'll choose Windows, and then we can specify additional parameters like confidence level, and then this outputs directly to a point feature class. Since I don't have one in my map, it will create a new one. I can give it a description and choose a symbology, a vertical bounding box. The process loads the model, and then it goes off to detect those points. And once it detects them, it creates a feature class, a layer for it, and sets the symbology for that layer. The result layer includes information, such as width, height, and heading of the window. And from these values, we can symbolize the boxes, so it is oriented and sized in the correct direction. But sometimes, objects like trees can get in the way, so we might need to do a bit more. Since we are part of a larger system, we can use the Create Profile tool, which lets me digitize that in and get a clipped out view of just that section, and I can run it here. Here we are in a different drawing mode, in a clipped out extent, really focused in just on those windows. I exit the mode and I've got my features. Another scenario can be analyzing the line of sight from multiple windows to a specific target point and observe how it is being affected from the new construction site. First, I will use the Construct Sightlines tool to create the 3D lines connecting all Windows points to my target point. Then, I will use the Line of Sight tool, which will analyze the visibility using these lines, and new in ArcGIS Pro 2.7 using an integrated mesh as the input surface. The result would let me examine how the new building is affecting the visibility. Using complex deep learning process followed by geoprocessing tools in 3D is easier than ever. Thank you.
That was just awesome, Igal. What I love about this demo is how it combines deep learning with so many analysis tools in ArcGIS Pro. AI has the highest reach and the most impact when it is used to solve real-world problems through focused apps and solutions. To do this, we are infusing AI into ArcGIS solutions. The 3D Basemap solution, for example, has been enhanced to use the tree point classification model to extract trees from LiDAR data. This helps users create more realistic 3D basemaps for their community. Similarly, you can create AI-infused apps and solutions using the development frameworks in ArcGIS like Survey123 or App Studio. Let's now go to our last stop, the city of Johns Creek in Georgia, where Nick will show us how he did that. Over to you, Nick.
Johns Creek is a mostly residential suburb of Atlanta, Georgia, located about 45 minutes from downtown. For years, we always wanted to have a comprehensive tree inventory, but we never quite knew how to get started. That was until we found out about the deep learning capabilities within arcgis.learn. The goal was to build a smartphone application that would help citizens both map trees as points and classify them. Let me show you what we did. First, we had to set up our training environment. That meant installing ArcGIS Pro, along with the deep learning frameworks, which include the ArcGIS API for Python, the feature classifier, TensorFlow, FastAI, and Torch. Once the foundation was in place, we had to collect our training data. Thankfully, a great organization named Trees Atlanta maintains a list of the top 50 tree species in our area. We used that list to find about half of our samples from the plant cleft dataset. The other half we had to curate on our own. It was critical that we got equal numbers of image chips for each class so that we wouldn't under or over train any single class. This is where the real fun begins. We used the Jupyter Notebook environment within ArcGIS Pro to help train our model. First, we had to specify the path to the image directory. Then we specified the batch and chip size. Once we loaded the feature classifier model, we started training the model. Training our model of 50 classes, each with 100 image chips, took about 6 hours on our 8 gig GPU. Once we were satisfied with the model's predictions, we saved the model as a TF-Lite file. The final step was to switch to Survey123 Connect and App Studio. With Survey123 Connect, we built a custom survey on our desktop using the Smart Camera template and then uploaded it to ArcGIS Online. Then we switched to App Studio and used the Survey123 template app to build an app that would only use that survey that we had just created. Once we were done, we went ahead and compiled the application for both iOS and Android and released it to the app stores. The result is a very lightweight, deep learning enabled smartphone application that our citizens can use to collect both tree locations and their species. Thank you.
Thanks, Rohit, and our special guests for giving us a quick tour of geospatial AI. This technology is built to deliver an intelligent GIS for all users, a GIS that can sense and learn and adapt, and in the process improve as data flows through the system. Here at Esri, we are working on advancing spatial science so that you can continue to address the world's greatest challenges.